Dear friends, welcome to the next problem of belt drive. That problem number 12. Data is like this. A V belt weighing 1.6 kilogram per meter run has an area of cross section of 750 millimeter square. The angle of lap is 165 degree on the smaller pulley, which has a groove angle of 40 degree. Take mu is equal to 0.12. The maximum sap stress in the belt is 9.5 Newton per millimeter square. What is the power that can be transmitted by the belt at speed of 20 meter per second? Let us note down the given information in the problem. Here the mass of the belt per meter length is given. M is equal to 1.6 kilogram per meter. The cross sectional area of the belt is given 750 millimeter square. Angle of lap on the smaller pulley is given 165 degree. The groove angle of the V pulley is given 2 alpha is equal to 40 degree. So alpha is equal to 20 degree. Coefficient of friction mu is 0.12. The sap stress in the belt material is F is 9.5 Newton per millimeter square, and we have to calculate the power when the belt speed is 20 meter per second. We know that the power transmitted by the belt is given by P is equal to difference of two friction tensions, tight side tension T1 minus slack side tension T2 into belt speed. Here we need to calculate tension T1, T2, V is already given. So we will use the maximum tensions induced in the belt to calculate T1, and that T maximum tension induced in the belt is given by T is equal to T1 plus Tc, where T1 is the tight side tension in the belt and Tc is the tension because of centrifugal force. Here T is given by the maximum safe stress into cross sectional area, and that is F into A. The values of these two parameters are known to us. So F is equal to 9.5 and A is equal to 750. So we found in calculation the maximum tension T is equal to 7125 Newton. And Tc is equal to centrifugal tension, that is given by mass per unit length into speed square, that is mv square. Substituting the values, m is equal to 1.6 and v is equal to 20. So we found centrifugal tension Tc is equal to 640 Newton. Now, using relation to, that is T is equal to T1 plus Tc, rearranging the terms, we found T1 is equal to T minus Tc, and both these values are known to us. So substituting, we found T1 is equal to 7125 minus 640, that gives tight side tension T1 is equal to 6485 Newton. And for V belt, we know the relation between two tensions tight side tension and slack side tension. It is given by T1 upon T2 is equal to e raised to mu theta divided by sine alpha. Here theta is measured in radian, which is given is equal to 165 degree. So theta is equal to 165 into pi upon 180 is gives 2.879 radian. So we substitute the values in relation of T1 and T2. We found T1 upon T2 is equal to e raised to 0.12 into 2.879 divided by sine 20 degree. And on calculation it gives us T1 upon T2 is equal to 2.746. So T2 is equal to T1 upon 2.746. Substituting the values of T1, we found T2 is equal to 2361.62 Newton. Using the values of T1 and T2 in relation 1, we found power transmitted P is equal to T1 minus T2 into V, that is P1 is equal to 6485, T2 is 2361.62 and V is 20. That gives us 82,467.6 watt and can be written as P is equal to 82.47 kilowatt. So we conclude that the power transmitted by build at given speed is 82.47 kilowatt. Thank you friends.